Okay, we are going to go over 9B. This is Mrs. Eider. We are going to learn how to simplify radical expressions. And radical expressions are just these little square root things. So let's look at what a radical expression means. So a square root, what square root even means? It means if we have a square and the area is 16, what we want to find is we want to find what the side length is. That is what we call the root. How we would write a problem like this, it would look like this. If my area, this is where the area is, needs to be equally divided between two sides, that's what this symbol means, is we are going to take all the factors of 16 and we're going to equally divide them between the two sides. Now, if we look at this as a picture, what that looks like with 16 bricks on this looks like this. And it's easy to tell that from there, each of the sides, this is going to be 4 by 4. 4 by 4. So the square root of 16 is 4. Each of the sides of a square are 4. Now, how do we do this without all of the square root things? What does this look like when we're talking about it mathematically? If we need the square root of 16, what we're going to first need is we're going to need all of the factors of 16. We can use our sheet that we had from chapter 8 notes that has all of our factors listed, or you can break it down using a factor tree. So all of the things that I have that need to be distributed evenly to the sides, I have a 2, which is this 2, and I have another 2, and I have another 2, and I have another. And if I evenly split these to each side, what's going to happen is I'm going to give this 2 to this side. I'm going to give this 2 right here, goes here. I'm going to give this 2 to this side. This one is going to come here, and this one comes here. And if we multiply these, we get the same answer as we did before when we drew the picture. If my area is 16, each of my side lengths is 4. Now, let's try this a little bit on a couple of these. If I have a square and the side length is 6, because all squares have the same side length, I know this one is also 6. If I have a square or if I have a cube, in order to find the volume of a cube, that's going to be length times width times height. So on this one, that would be a 6 and a 6 and a 6. Now, we're going to also be given some easy cheat sheets that we're going to be using, which are right here. If I have these two together, what I need to make sure that I have on here, we're going to label this a little bit. This number over here is talking about our side length. This will kind of give us a list of perfect squares so that we don't have to do this the long way coming up. This side over here, this is our area. So if our side length is 8, then we can see that our area of our square would be 64. And this is going to go the same way as well on the other side. If my area is this number, so we're going to label this as area. If my area is 64, then I can tell that my side length, let's undo that. I can tell that my side length is going to be 8. So this represents side length. Now, this is going to also apply to cubes. This side, the first side, is my side length. If my side length of a cube, like the one that we were just looking at, if my side length of a cube is 6, then I know that taking 6 times 6 times 6 is going to give me my volume. So this side over here, this represents volume. Now, what that comes in handy for is when we are doing problems like the one we were just looking at right here. If we have a volume of 512 and we need to know what our side lengths are, length times width times height, then we can look over at our cheat sheet that we just had. Let's get over there. We can look at our cheat sheet. And let's see if I can. On our cheat sheet, we can see that if we look and see where 512 is, 512 is right here for volume. And I can look right here and see, oh, that means my side length on that guy is going to be 8. This is going to be super helpful. Maybe. This is going to be helpful if we need to find side lengths of this. So this would be 8 and 8 and 8. That also works for a square. If we look over on our perfect square list and we see that the area is 25, we can see that our side length is 5. So that's going to help us with what we need to do as far as this is going to be our shortcuts. So we're going to just write, this is our perfect squares. These are perfect squares. Sometimes they're going to be listed on here, and sometimes we're going to have to do something a little bit trickier with those. So let's look and see what a square root even is. So when we're talking about numbers and we say, if we have 7 and we add 2 to get, if we add 2 to 7, that takes us to 9. And if we need to get back to 7, then we're going to subtract 2. Now, instead of doing both of our add 2 and get to 9 and then subtract 2 and get back to 7, technically we know that the plus 2 and the minus 2 are opposites of each other. And what they can do is they can just eliminate each other. Plus 2 minus 2, these two are opposites. So we can just get rid of them. So 7 plus 2 minus 2, these cancel each other out. Now, what if we did multiply? 7 multiplied by 2 takes us to 14. And to get back to 7, we're going to have to undo that, which is divide by 2. And we're going to use the same logic here. 7 times by 2 divided by 2. We know that these two things can cancel out, which leaves us just with 7. Now, here is where we run into the new stuff that we haven't talked about before. If I have 7 squared, that is 7 times 7. And that takes me to 49. In order to get back to 7, I could divide by 7, but we already know that divide is up here with multiply and divide. So we need to find out what is going to be the opposite of squared. The opposite of squared is a square root. And the same way that we in an equation can go 7 plus 2 minus 2 and those two cancel out, if we notice on here, we can take the squared, we're going to take the squared and the square root, and they can cancel out and leave us with the number of 7. So, and that works with anything. It works if we have x squared and then we have a square root. Those two things will cancel each other out and just leave us with x. So that's how the squares and square roots actually are related. And we worked a lot with with squares last chapter. Now let's look and see how we're going to factor something. If we need to factor something like we did with the 16 when we started, and it doesn't come out evenly, like it did with these squares, let's see what we're going to do when we have this. So on 64, if you think about, let's go look and see what all of the factors of 64 are. 64 on my prime factorization chart breaks down to 2. There are 6 2's. If I have to evenly divide those 6 2's between the sides, each side would get a 2. So that means 2 times 2 times 2. Each of these sides is going to be 8 as my number. Now, what would happen if I have 6 x's that I needed to, let's get rid of these 2 so we have some space. If I had 6 x's that I needed to divide up in between 2 sides, each side would get 3 x's. And if I have 3 y's and I need to split up the y's evenly between 2 sides, each side is going to get a y, but then I got this left over. And the same way that we did remainders, like 4th grade, where we have like a 13 divided by 2, and 2 goes into 13 6 times, and we get down to here, and if we don't want to write it with decimals, we have 6, and then we have a remainder of 1. When we are simplifying radicals or finding what the square root of a side is, square root of an area is, we are going to also treat whatever we have left over as a remainder. And how that is listed when we're talking about radicals is it is a remainder, and then whatever is left over gets left there. So the correct answer, this correct side length for this problem that we just worked on is 8x to the third y with square root of y. That's the remainder that needs to be split evenly between those two. Now, what that would look like, if I'm trying to look and see what a problem like this would look like if it did not have a box here, which some of your homework will not have a box. It will just have a number that looks like this: 64, x6, y3. This and this picture, these are the same. If you have an equation that looks like this, if you have an expression that looks like this, it's saying the same thing as if we have a box, what are the side lengths? Now, let's look and see what would happen though if we had a 64 as my volume. If I have 64 as my volume, now I know that I got to split this up between 3 sides. I still have my prime factors of 64 were 2's, and then I have 6 x's and I have 3 y's. If I'm going to split these evenly between the sides, each side would get a 2, and each side would get another 2. So 2 times 2 so far. And then if you notice, I have 6 x's, so each side would get 2 x's, and I have 3 y's, so each side would get one of those. So my final answer for this one would be 4x squared y. Now, what that looks like if I'm looking to write it out as an equation to begin with, is this is 64 x6 y to the third, but because I'm splitting it up 3 ways, I got to put a 3 here. And anything that I have that's left over, all of my leftovers when I'm talking about a cube are going to be left with a little 3 here. That means we've got to split that thing 3 different ways. So let's try a couple problems and see if we can simplify what we're going to do. Let's try this one. Let's try the first one. If I look on my cheat sheet and I see there's 40, 40 breaks down to 2 times 2 times 5. And then I have 4 x's and 5 y's. If I'm looking for things that I can split up between the two sides, I'm going to put here in the front, I'm going to put where all of my matches go. And I can see that I have a match right here of 2's, so each side is going to get a 2. And already I can see that I have a 5 that's going to be left over, so I'm going to put a 5 here. So the number part of this one is done. Now let's look and see what happens with our x's. If I have 4 x's, I know that each side is going to get 2 because I'm just splitting them up 2 ways. And if I have 5 y's, each side is going to get 2, and there's going to be 1 left over. So final answer for this one's going to be 2x squared y squared with the remainder of, or radical 5x. This is your match. And this is your leftover. So you have 2 parts, match and leftover. Now we have to be careful because sometimes it will ask us for an estimate answer, which we're just going to plug this dude in our calculator. And sometimes it's going to ask us for an exact answer. An estimate answer example for this one is 8.89. I don't remember the decimal, the expansion of this. But we have to round it off. If you have to round it off, this is going to be an estimate because we cannot give an exact answer. We've left something off. If we're going to do an exact answer, what this is going to look like is it's going to have whatever matches and whatever's left over, or our remainder. 72 on my cheat sheet breaks down to 2 times 3 times 3 times 2 times 2. So I'm going to be looking for anything that is a set that I could split up between the two sides. Each side would get a 2. Each side would get a 3. And my leftover goes right here. So the exact answer on this would be 6 square root of 2. So be careful when you're doing your assignment to make sure that you know whether it's asking for the estimate answer or the exact answer. Exact answer is going to be with square roots. Estimate answer is going to be on a calculator. Now, let's try a couple. Square root of 24. Estimate on a calculator, I can tell that this is going to be just below 5 because square root of 25 is 5. So estimate on this, 4.89-ish. If I'm doing an exact answer, however, I can know that this breaks down to 2 times 2 times 2 times 3. So I'm going to be looking for my matches and my leftover. My matches, each side would get a 2. And my leftover, 2 and a 3. And then I'm just going to times whatever's left. So this is 2 square root of 6. Let's try the next one. On this, I'm just going to do exact answer on this. For this one, it is not on your cheat sheet, so you're going to have to do your own little bit of division. So if I have 300, I know that this breaks down to 3, which is prime, times 100. And then on my cheat sheet, I can look and see that the 100 breaks down to 2 times 2 times 5 times 5. So on some of these, you're going to have to do some of your own math. From here, I'm going to look for matches. My matches go out front. My leftovers go in here. So I have a 2 that can be split up evenly. I have a 5 that can be split up evenly. And my leftover goes right here. So this one would be 10 square root of 3. And that's what we're going to be practicing today. Now, just so that you get a practice, try pausing the video and practice simplifying this one, and then play the video and see if yours matches. On this one, we are going to break this down. It's going to have a 2. I got to do my math in my head. This is 10 and 12, 2 and 5, 2, 2 and 3. So we have 3 2s and a 5 and a 3. So my matches on this one is a 2. And my leftovers are all of these parts. We're going to multiply all of those, and that's going to be 30. So 2 squared of 30 is my final answer for this one. So try a few problems. If you have any questions on these, send us an email and let us know what your questions are, and we'll go over some with you.